This study proposes a novel design methodology for tendon-driven continuum robots which are embodied to bend in desired bending profiles like constant curvature and logarithmic spirals. The study exploits the kinematics of stack of disks rolling on top of each other. Here, for equal radii disks, the stack bends in circular profile at each instant, whereas for a stack with radius decreasing in geometric progression, a logarithmic spiral is obtained. These will be called CCECR constant curvature embodied continuum robot and SECR spiral embodied continuum robot respectively. To convert the model to design, we begin with a revolved hollow symmetric geometry, here a frustrum for SECR, similarly a cylinder can be chosen for CCECR. The discs are then imposed on the geometry creating these contours at the edge which can be extruded out, mirrored on the opposite side and repeated on the perpendicular plane. And finally adding the tendon routing holes, we can obtain the SECR design. Similarly, the CCECR can be obtained from the cylindrical initial geometry. To validate the design in simulation open framework architecture so far using finite element analysis, the obtained design is meshed and mapped with tendons and simulated over step displacement. The central spine of the tendon-driven continuum robot has a maximum deviation of less than 4 mm in case of SECR and less than 2 mm in case of CCECR as shown in the plots. The design also has the capability to contract and change its length, increasing the workspace of the robot while it can still bend in constant curvature and logarithmic spirals. The SECR and CCECR are then fabricated using thermoplastic polyurethane TPU material using 3D printers and mounted on a plastic base with motors and pulleys. Physical experiments demonstrate the capability of the robot to bend in constant curvature in full and half lengths. Here, the robot can be seen contracting and also bending in contracted state, still sticking to the constant curvature profile. Similarly, the SECR can be seen bending in logarithmic spiral and also contracting to change its length. The SECR robot can also grasp different objects mimicking the nature of creatures like elephant trunk, octopus tentacles, etc. Thus concluding that the idea of rolling discs can be exploited to design dependable tendon-driven continuum robots and obtain desired bending profiles while having a flexible workspace due to its contraction capabilities along with cheap and simple manufacturing. Thank you.